All right, students, today we'll be looking at section 8.6, square roots and irrational numbers. And in case you've forgotten, you do have a quiz that you will take before you do this section, and it'll be over all of the sections over area and perimeter and circumference that we've covered so far. So sections 8.2 through 8.5, you need to go back and review over those for your quiz. And once the quiz is finished, then we'll take notes and do worksheets over this section. It's a very short section. So square roots and irrational numbers. So let's first take on square roots. So a square root is going to be written like this, and this is our first two examples. A square root is simply saying, okay, what number times itself? So what number, when it's squared, equals this? It's almost like you have to work backwards in a way. So remember what squaring looks like. So remember, so like 2 squared is 4, okay? So 2 squared equals 4. Well, the square root of 4, which we have right here as our answer number B, would equal 2. So you can go ahead and write down 2 right here. Well, if I were to square something like, let's say, 4 squared equals 16, so the square root of 16 is 4. Okay, you see that? If I square this, I get this. If I take the square root of this, I get 4. So it's kind of like undoing each other, like multiplying and dividing are opposites, adding and subtracting are opposites, squaring and square rooting undo each other. You're left with the 2. You're left with, the 4. Same thing. So, what is the square root of 49? Well, that would be what number times itself, what number squared equals 49? Well, that would be 7. And we already answered B right there. Okay, so hopefully we get that. Let's think about this. What about, let's do a few more. Let's do C and D. What would be the square root of, let's say, 25? What times itself equals 25? Well, that would be 5, right? Okay. And then you need to, for D, let's put down the square root of, let's say, 64. Now there's a lot of numbers I could multiply to get 64, but what number times itself equals 64? Well, that would be 8. 8 is the answer we got there. Cool. What I want you to do now is over here write down this. I want you to write down the word perfect squares and put a question mark by it, because I want you to ask this question in class. Write down the word perfect squares and ask me a question about it in class. Okay, next example. Estimate the value of each square root. Now this is when we're given something that's not a perfect square. What times itself equals 18? Well, there is no number times itself that equals 18. The only way to get 18 is 1 times 18 or 2 times 9. I don't know of any number times itself, at least any whole number. So that means there must be some kind of decimal. If I threw a decimal number in there, maybe that would be it. We could always type this on a calculator, but since it says estimate, let's just get close. And here's what we do. Think about the other square roots that work out nicely. Like, here's what we could do. Let's think about, the square root of 16. Square root of 16 is 4, and that's close. 16 is close to 18. And what about the square root of 25? That's 5, like we found up there. 18 is between 16 and 25. So if 18, let's put it right here, if 18 is greater than the square root of 16, but less than the square root of 25, and if this is equal to 4 and this is equal to 5, that would mean that the square root of 18 would have to be something between 4 and 5. So we could say 4.5. 5, like 4.5 or 4.6 maybe. It's a little closer, it looks to me, to 16. So maybe it's like 4.3. Yeah, let's say 4.3. And we're estimating. So long as you have 4 point something, you get credit on that since we're estimating. Next over here, what two numbers when multiplied together equal this? I don't know. Let's think about it. So what's it close to? Well, I could work my way up and say, well, 6 times 6 is 36. Not too close to that. 7 times 7 is 49. That's pretty close to that. It's a little bit smaller than it. And 8 times 8 is 64. Hey, that's a little bit above it. Hey, we found the two numbers that it's between. So if I have the square root of 49, and this guy right here is bigger than that, but he's smaller than the square root of this, and since 49 is square root of 49 is 7, square root of 64 is 8, this guy has to be between that. So we could say that the square root of 54 is maybe 7.4, maybe? That's a good estimate right there. So there we go. That's what you do, you estimate. You find out where does this square root, what does it fall in between, okay? And like I said, if you don't get what's going on here, put a question mark by it and say, how do you do this? I don't understand. Okay, you gotta write those questions down, guys, if you don't get it. Next, we have irrational numbers. It would be helpful for you to go back right now and look through your notes and find the section on rational numbers. Ding, 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 ding. If you did that, you would remember some things that would help you as we discuss irrational numbers. But numbers are broken down into this thing where you have whole numbers like 0, 1, 2, 3, 4, 18, 79, 28, all those things are whole numbers. Integers include whole numbers and their opposites, meaning you got 1 and its opposite, -1, 15, -15, 127, its opposite is -127. Integers. Rational numbers include all of those guys, plus all the decimals and all the fractions. Actually includes all the fractions, but not all the decimals. There was a special case. Remember, if it terminates, means it comes to an end, it's rational. If the decimal keeps going but it repeats itself, it's also rational. The only type of decimal that does not go on here is the decimal that goes on forever, it never repeats. So examples of irrational numbers are numbers like pi, 3.14, blah, 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 blah. Or this guy, 0.323223222, and you get the point. There's no part here where I could draw a line and find a repeating pattern. I might be able to predict what comes next, but I can't ever stop and say, okay, this is what's repeating, because it keeps increasing the number of 2's. Also, if you take the square root of a non-perfect square, it's an irrational number. So come into class and be able to answer these questions. What are some types of irrational numbers? In fact, why don't you think of some other numbers? Write some examples down for yourself and come into class and ask if they're right. If you come up with a really good one, I might give you a bonus point. Maybe, we'll see. So, see you tomorrow in class. Bye-bye.